Hi, this is how easy it is to program Nukeson Weldbot. First of all, we log into the system. Next thing, we need to enable the machine. Then we are going to the HR app. We can minimize this side. We're going to device and connect. With an air switch, we can test the gas flow, making sure that everything is working. If anything will have any problems with the welder, they will be displayed in here. We can clear the errors, and that's how easy it is. Next thing, we can go to task and we can create a new program, parts dash 112, and we can choose the arc job, which is predefined settings which we store in our crafting parameters. So in here we're going to choose arc job number 5 and the wave job number 1. So this is our main programming window. On the left hand side we do have all our tools which are for movement tools. In here we do have a linear and joint movements. We can use single points as well. We have a circular movement, offset specific points, or use the wave movement. We have our logic, if statements, loops and waiting. We have our input-outputs control system in here. We have our welding based options. We can turn the arc on, turn the arc off. We can manually push the wire. We can touch sense for interrupted welding. Everything is in here. Next part is we have a templates in here. So we have a linear weld template. So this is my personal best feature of this, because we're simply selecting linear template for specific weld we want to use, and that will predefine the start point, arc starting and end point of the weld as well. And that's according to circular movements, weave movement, G, multi-pass, interrupted welding and arc tracking template. To start with a basic program, I'll choose linear template. So that gives us the linear movement, arc on point, arc on, which is actually defined in the welding parameters, arc off and arc off for turning the welder off. So to generate the program, we would like to add extra linear movement in the beginning of it. So this will be our approaching point, so we can add extra points. So that will be our start point. So the next thing is we'll go to the robots. So what we want to use in here is a free button. So we have 2 buttons in here. Free button is literally freeing up the whole robot arm. The point button is defining the point, it's just saving the location. So we can just press the free button, hold it for 3 seconds, and that will go blue. And now we can move the robot arm to whatever the point we want to. So this will be our start point. So I just want to make sure this is all clearing all our jigs in here. We can freeze this up, holding the button for 3 seconds again, and this will go green, so the robot is done in there. So now back to here, we can simply press update point. So this point was updated. Next part, we will just select the arc on point, and again by pressing free button, we'll arrive into our weld start point. So what we're doing here, we're using our sort of experience on how the weld should look like and where to put the torch in. So what we need to do in here, as you can see, there's a wire protruding up from the welding nozzle in there, which is about 10 millimeters, and that's of course depending on the weld. But in this situation, that's how we can set the distance. And obviously we're aiming for the corner between the 2 plates in here, and that will be our start point. So next part is we can go back to the controller, update this point. So arc off point, we need to set up speed to around 50%. We're going to edit this point manually in here, so we can set up a step of movement 10 millimeters, because we want to define very specific length of the weld. In here we're going to be using the y-axis, and we're just going to move towards negative point. We want that weld to be 20 millimeters, so just select it twice. Press confirm to save. Last point, it will be to retract the robot arm. So we're going to use a linear movement for this again. And what we can use in here, we can use a predefined point which we use in the first instance. We'll press move here, robot arm will retract into original position. We can select this point and we can simply copy the same location. Right, so if everything is done the safe way, we can run the simulation of the whole program. So to run the simulation, just lower down the speed to around 30 to 40%. Make sure the whole program is pretty much safe to run. Press simulation. Right, that's very nice what we got in here. So there's one more thing I would like to add. I would like to add some waving into it. So right after our arc on, when the welder is starting, I would like to add waving into it. So by pressing wave commands, this will import that into a specific location. Then we can move the weave end right after arc off. By selecting the weave function, we can use the specified craft job, or we can select the specified, or we can set the specific craft job for waving, or you can use the manual settings. In here we'll try to set up for about 2 millimeters with 2.5 frequency, and we can remove the dwell and we can run the simulation again. So that will give us a full movement, including the weaves on it. To me, this is looking like very dense weld in there. So we can change that slightly. We can go back again to the waving, and then we can change our frequency, because I think this is a little bit too dense in here. So we can change this to 1.5 Hertz, and we can run simulation again. So pretty much by looking at the robot movements and according to your experience, that's how you can... After waving, we need to set up arc on parameters. So in here we can use the predefined craft job parameter, which we done at the beginning of the program. We can select an actual parameter from here if we want to change it, or we can use the manual settings for this. So in here we can use any of these modes for the welder. We can set up a amperage, voltage compensation, weld speed, which is obviously the robot movement. We can do arc on slope, we can do arc off slope. So everything is set up pretty much dialed into every single amp. So in here we're going to run this 5mm steel, that is stainless steel, and we're going to run it on 100 amps as we head it. All we need to do is just to confirm it, and then we're ready to run the actual weld. If we have everything set up like this, we can try to run the test weld. So to do that, we need to increase the speed to 100% and then press play button and start welding. So as you can see, robot executed exactly what it was programmed in. We can inspect the weld itself and then apply correction to the welding parameters, or to the waving parameters, or to position. I hope this helped you a lot. Thank you very much.